So hi guys, in this video we will be discussing everything that was asked in JAM Mathematics 2026 under real analysis. As we know that in the last couple of days the response keys has been released, and we have grouped all the question under each topic, and we have taken every question that was asked under real analysis, and we will be discussing those questions in this session. So here we can we have provided you the timestamps in the YouTube video so that you can skip between the questions if you have understood the answer to the question at any point of time, right? And also the solution PDF that we will be solving here, this PDF will be attached in the description box, so you can download it from there as well. Here the question that will be discussed will be complete solution, and it will be 100% accurate, and we are not leaving any question here, right? And we will be not solving each question in detail, because that is not the purpose of the examination. In the examination you have 3 minutes per question. So apart from the goal being solving the question, my goal here will be to solve the question in the exam mode, as if I am appearing, I am there in the examination hall. So the solution would not be lengthy or will not be very short. It is as per requirement, if nothing more, nothing less. So let us start with the first question. The first question that was asked was from sequence and series, and okay, let us read the question. So the sequence is already given to us. The sequence is oscillating between -1 and 1. So if I write the sequence, the sequence looks like -1 1 -1 1 -1 1 and so on. And we have to find out which one of the following option is false. So you have to keep in mind that whether false was asked or correct was true was asked, because I have seen that in this examination the confusion was introduced with this notation as well. I mean, in half of the question, not half, in most of the question they have asked which options are incorrect or false, like that. So yeah, so in all of these 4 options we can see that this quantity was computed, right, and was asked about it, right? So let us first understand what this quantity is. So here the sequence is like this, right? So for this n is 1, for this n is 2, n is 3, n is 4. So n here is the index of the sequence. So for the first index, that is the first item of the sequence, that is -1 and 2 1, then -1 1, etc. So here m and every notation is for the indexes only, right? If we understand these things, we can easily understand the solution of this question. This is a very simple question. If you just understand the notations, it will be very easy, right? So xn is either -1 or 1, right? N stands for any index, right? It is either -1 or 1. So xn -1 is either -2 or 0, right? If I subtract 1 from this, if I take mod, xn -1 is either 2 or 0, right? Now let us start evaluating option 2, because option 2 looks a bit simpler. It is saying there exists epsilon greater than 0 such that this quantity is less than epsilon for every positive n. For all the n, it is saying, for all the n they are commenting, right? So this quantity less than epsilon means 2 is less than epsilon and 0 is less than epsilon, because it is saying for all positive n. So for all the positive integers, this quantity is either 2 or 0. So epsilon should be greater than 0 as well as it should be greater than 2 for this statement to be true. So if I take epsilon as 3, this statement is always true, right? This statement. Why? You can think about it, right? So xn -1 is less than 3 is correct, obviously, because xn -1 is either 2 or 0. So it is saying there exists epsilon greater than 0 such that this thing is true. Yes, right, it is correct, right? Because I can take any epsilon that is satisfying this 2 condition. If I take epsilon greater than equal to 2, this condition will be satisfied. So there exists such epsilon. If here okay, this option is already true, so this is not our answer. Let us check option 1. Option 1 is saying for all epsilon greater than 0 and m greater than 0, there exists a positive integer such that if n is greater than m, this condition should hold, right? Let us see what it means. So if I write my sequence as -1, 1, -1, 1 and so on, right, never ending sequence, there exists positive integer n and m. Let us take a positive epsilon, right, because it is saying so. Let us take m greater than 0. So m means the index of the sequence. Let's take any index. So let's say this is my m, this from -1 onwards. So it is saying there exists a positive integer n which is greater than m. So n can be any of these indexes, right? So xn can be either -1 or 1, right? If I take m anywhere, any index after that can have value -1 or 1 only, right? There exists a positive integer n such that n greater than m, and xn minus 1's mod should be less than e. So xn minus 1's mod will be either 2 or 0, right? Sorry, greater than e, right? So let us reframe the question. Let us re-understand the question. So it is saying for all epsilon greater than 0 and for all these indexes, there exists a positive integer, that means index after that index after that m, such that this condition holds, right? So to hold this condition, epsilon can be either 0 or 2. It is not that end kind of situation, because it is saying that there exists a positive integer. It is not saying that for all positive integer it should be true. If it would have been for all integers, we could have taken we should be worried about every value that is coming after m, after index m, but here there exists, just there exists, right? So is it true? Is it true, guys? So epsilon can be either less than 0 or it should be less than 2, but epsilon is greater than 0. It is already given to me, right? So this is false, but epsilon can be less than 2 as well. So if I take epsilon as 1 or epsilon as 3, let's say epsilon is 3, then this is incorrect, right, guys? Because it is saying for all epsilon greater than 0. It is not saying there exist. If it would have been there exist, I could have taken epsilon 1 that is satisfying this condition every time. But if I, let's say, take epsilon equal to 3, then 2 is not less than 3, right? So this option is false already. So this is my correct answer to this problem, but we will discuss remaining option as well, right? So option 3 is quite similar to that. So option 3 is saying for all epsilon greater than 0, m greater than 0, there exists a positive integer such that this is less than epsilon. So it is saying 2 or 0 is less than epsilon. So epsilon can be greater than 0 or can be greater than 2, anything can work, because this only difference between 1 and 3 is this sign only. The meaning, this part's meaning is the same for all of these two options. So the third option will be true if epsilon can be 0 or 2, anything can work. So it is saying for all epsilon greater than 0, it will satisfy this condition already, right? If I take any epsilon greater than 0, it will be greater than 0 only by definition. So this is true, because we know for OR statement to be true, any one condition must be true, right? So this is true. So this cannot be the answer, but you can skip this question because we already have arrived at the answer. But if you want to discuss more, that is why, if you want to see each and every option, that is why we are discussing till now, right? You can ask doubts in the comment section if you have somewhere. So option 4, let us discuss option 4. Option 4 is there exists epsilon greater than 0 such that for all m greater than 0 there exists a positive integer for which this is true. So okay, let us discuss this option. So it is saying there exists. I have already given you the spoiler of that in these two options. Such that for all m greater than 0. Okay, let me write the sequence: minus 1, 1, minus 1, 1, minus 1, 1, and so on. So for all m greater than 0, so if I take any m can be this value, this value, this value, any index. Let's say m is this, right? Let's say m is this. There exists a positive integer n greater than m such that this condition holds. So there exists. So I take any n after m. If I take any n after m, xn can be minus 1 or 1. So xn minus 1's mod is either 2 or what? Either 2 or 0. So this is true, right? If I take m here as well, then also xn can be either minus 1 or 1, or xn minus 1's mod is either 2 or 0. That is true, right? So it is saying that there exists epsilon greater than 0 such that okay, for which this condition should be true. So there are two there exist. So before that, I will tell you one thing. So this option will be true if I can show any positive integer. There can be one positive integer also, then also that will be true, right? So if xn minus 1, okay. So if I translate it, it is saying xn minus 1 is what? Xn minus 1 is greater than epsilon. So if I translate it, it will be 2 or 0, right? Will there exist an epsilon for which this condition is true? Will there exist a positive epsilon for which e is less than 0 or e is less than 2? Any condition can. So if e is positive, this is not correct. But if I take e as 1, this will be correct. So this option is also correct, right? So this is false. So this is the solution to question 1, that is from sequence and series. I have already told you that we will not be spending much time, but this question required us to understand, right? Now question 2 is pretty easy. If you see question 2, there has not been a lot of information given, but if you have a feel of function, then you can easily solve it without actually going into the concepts of real analysis. So let me just give you the intuition of how can you solve this. So we know that a function is defined from 1, 2 to r. So if I draw a graph, a rough graph, let's say, so this is 1, this is 2, and there is a continuous function in between these interval. Continuous means I am continuously drawing a graph. So let's say if you have given a task of drawing this function, so if I just draw 2 vertical lines, yeah, so if I were to be given to draw this function, I mean this function can be anything, right? So I can draw a function like this, I can draw a function like this, I can draw a function like this. Any function, any continuous function will satisfy the definition of this definition that there exists a function. Now there are two values given. So f of x when x tends to 1 plus, that means the point where the function starts here, and the point, because it cannot start exactly at 1 because it is open 1 to 2. So it will start just after 1, the next real number after 1. So you can just imagine that it is just touching this line, very close to this line. So f of x is 3. Let's say this value is 3. So you have to start your function at 3 and you have to finish your function at 3. So previously we were drawing the functions, every possible functions, but now there is certain restriction that you can draw the function, but you have to start from 3 and finish at 3. So okay, let's try drawing some function. So my function can be this, 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 right? So why I am drawing the graph, why I am not solving it from the theory and bookish method? Because it is not required. It just need a feel of mathematics, right? So obviously, right, if you are starting from 3, you have to come back to 3. Then let's say you are going upward. If you are going upward also, you will return after a certain point, right? Obviously, right? even if you are going downward, you have to return after a point, right? You have to return after a point back to 3. That means your function will be bounded by definition, because you have to return, right? You have to return after certain point of time. So your function is bounded between, let's say, these two lines, right? Or let's say you are going up and then returning, then also your function is bounded. Let's say you are going like this, then also your function is bounded between these two. So your function is bounded by definition, because you have to return after a certain point. You cannot go till minus infinity or plus infinity, because if you are going to plus infinity, that will not satisfy this condition. Why? Because what is the meaning of going to infinity? The meaning of going to infinity is that the value is not defined. Value is not defined. I mean, you cannot calculate f of, let's say, at x, f is tending to infinity. You cannot calculate the exact value. But if you are drawing this graph, you will stop at a point. You will definitely stop at a point that is not infinity. Infinity is not a number, it is a symbol, right? Infinity is like you are going out of the bound of the real plane, right? So f is bounded is my correct option. So f is unbounded, this option is eliminated by default, right? Now if f is bounded, I already drew the graph, it will either have a maximum, it can have a maximum, right? If I draw a function like this function satisfies these two conditions, and it has a maxima, right? And it has a minima as well, because it is bounded between 2 and 3. So if a function is bounded, then it will have maxima and minima by definition, if you have studied real analysis. So if f is bounded, this option is false, because it is saying it will have neither a maximum or nor minimum. So it is saying f is bounded, f has maximum or minimum, but not both. By definition, a bounded function has to have a minima and maxima, right? I have shown you the examples as well, right? So this option is also incorrect. So the correct option is option 1. Next question is question number 3. Question number 3 is a very good question. Will not be solving again through the bookish methods. We'll have a feel of it, right? Now it is saying f from R to R is a twice differentiable function, such that f of n is equal to 1 for all n belonging to integer, right? So it is saying that the function is differentiable, but one condition is that in integers, let's say it is 0, 1, 2, 3, minus 1, minus 2, and so on. So in integer it is taking the value 1. So it is twice differentiable, but it is taking a value of like that, right? Now if you are seeing this, if you want to check the option, so it is let us try the option 4. F dash of n is equal to 0 for all n belonging to integers. Is that true, guys? Because I drew the graph already, right? If my graph is this, let's say like this function is differentiable. Why? Because if you have studied differentiability out of the definition from the graph point of view, if a one variable function is differentiable if it have a smooth edge, not sharp edge, right? Smooth edge and sharp edge, there are two concepts from graph point of view. Let's say I draw the graph of mod x. So mod x is not differentiable at x is equal to 0. Why? Because this edge is a sharp edge. But the graph of y equal to x square is differentiable at x equal to 0. Why? Because it is a smooth edge like this, not a sharp edge like this, right? So this function is differentiable because I am creating smooth edge, and I can create such a function where the value at integer is 1. But here you can see this is also acceptable, right? Because it is satisfying this condition, right? But you can see that here the derivative is not 0. So f dash of n is 0 for all n belong to z is wrong, definitely. Now what is the meaning of double derivative, guys? Double derivative means the rate of change of slope. So if double derivative is 0, I mean that means f dash of x, I mean the rate of change of the derivative is I mean okay, let me explain from graph point of view. So through words, I mean that will not be clarified. So as you can see that here we are encountering minimas, right? So in minima we know that double derivative is less than 0, sorry, greater than 0. So this is already false, because in for all n belong to z it is not true, because I can show a counter example, right? Now one question you might have is that we do not have graph, we do not know about the function, so how can you draw this graph and make conclusion based on this graph? That is a valid question. I appreciate the person who asked it, but the question itself is not restrictive. This question is saying that a function is there that is from r to r, that means it is in the xy plane, right, and it is spanning like this, and it is going up and down, anywhere it can go, and it is a twice differentiable function. So is this function is twice differentiable? Obviously it is, right? It is like a sine graph or a mix of sine and other graphs. It is twice differentiable as you can see, and we are set, and it should have f of n is equal to 1 for all of these integers. So it is the line y equal to 1. So at integers the graph must touch this line or cross this line, right? So that is also satisfied. So there can be infinite functions that will satisfy this definition, but for it is saying that which option among them will be necessarily true. That means whatever the function, I mean let's say there are 100 functions that satisfy this condition. So for these 100 functions, one of the option will be necessarily true irrespective of the function, right? So that is why I can take any function, any one function that belongs to the family of the described function, and I can eliminate option based on that. You can do such a thing. You have to do such a thing in the examination hall, right? Otherwise, if you do a bookish way of solving, that can take time, right? I'm not saying that is a wrong approach, but if you do not have a very high amount of practice of the questions, you cannot solve this method in a bookish manner very speedily, right? Now let's see at this option. Let's look at this option. If I draw this graph, let me draw one more function that is belonging to the family of this function. Let's say this is my x-axis, and this is my line y equal to 1. I can draw a function like this, right? Same function as this, but it will not cross like this. It will be like this only. Let's say this is integer values, where the value is getting 1. In each of these, so if I draw this function, you can see f double dash of x is positive, right? Positive and negative. Right? So here f double dash, this is a maxima, right? So in the maxima, f double dash of x is negative, and here it is positive, right? Next, if I see this option, f dash of x is equal to 0 for many x that is in between this. So in between these two integers, in between integers and real numbers, so r minus z is basically this space, this and this included, subtracting these points. So it is the same logic as the logic that we drew graph for this function. So let me explain you for option 2 and why it will be the correct answer. Let me just explain you. So we know that my function will pass through the point minus 1 comma 1, 0 comma 1, 1 comma 1, 2 comma 1. I know that my function will pass through these points. definitely, right? Because that is given. So if my function is passing through this point, so let's say I am not seeing all the graph that is in the left side of this and right side of this. I am just seeing the graph here, right? So let's say my function was touching here, it is touching here, touching here. So let's say my function goes upwards or downwards. It can go upwards or downwards, or it can go in the straight line manner, obviously, right? So even if I go upward or downward, I have to return to this point, right? Even if I am going upward and then going downward, I have to return at this point. So returning, the concept of returning, if you return to this point, you will create a point where the slope will be 0. That will be either maxima or minima, local maxima, minima. So if you are starting from here, you have to return to this point. I do not care, you are returning like a parabola, as you can see, or you can return like this, not a smooth parabola. But here you will create a slope 0. Right? It is from LMVT. So LMVT says, I mean, I am not a fan of the bookish theorems, but if you want to understand it from books theorem, you can actually understand it. So okay. So let us take these 2 points. LMVT says that there will exist a C belonging to 0, 1 such that f dash of C is f of 1 minus f of 0 by 1 minus 0. And f of 1 and f of 0 is basically 0, right? Because these are same values. So this is the essence of LMVT. I explained you LMVT from the, and not LMVT exactly, this is Rolle's theorem. And LMVT, I mean Rolle's theorem is a special case of LMVT. So Rolle's theorem from a book point of view is this. I mean the equation is this, that if f of A is equal to f of B, then you will find a C belonging to A comma B such that f dash of C is 0. That is the meaning of this, is that if two values, if function is taking two same values, then in between a slope 0 has to be created, right? That is what I explained from graphs. But if you want to understand from books point of view, then this is also correct. So LMVT or Rolle's theorem basically is saying that for any given 2 points, you will find an intermediate point where the slope will be 0. So this option will be correct. So f dash of x is 0 for infinitely many x, because for each of these pairs you will find a point that is not necessarily the middle point, but any point in between. So there are infinite points, right? So question 3's correct option is option 2. So if you are liking this video, you can actually comment that this video is helpful, or the approach that I am using to solve this question, the practical mathematical approach, is useful, or yeah, you can share among your friends. Okay guys, now we'll discuss question 4. So question 4 is about, again, sequential series, about the convergence of sequence. So we have been given 2 sequences, we have to comment on whether it is convergent or not, right? So yeah, so what is the meaning of convergence, guys? So if an is a sequence, then what is the meaning of convergence? If limit n tends to infinity, an, if this exists, then we say that the series is convergent. Or through the exact definition of convergence, you can go that if the epsilon delta definition, right? But that is the same thing, that is the same limit definition only. So if I take yn, for example, yn is equal to 1 plus 1 by 2n raised to the power 3n. So let us find out if limit is existing or not. So it is basically limit n tends to infinity 1 plus 1 by 2n. So this is similar pattern, right? If you recognize this pattern, we were calculating the limit of such functions right in the limits chapter as well. So the limit will exist if you have seen this kind of thing. So you can actually skip solving this and move on to xn. So that is how you speed up things in the examination hall. But nonetheless, we know that limit n tends to infinity 1 plus 1 by n raised to the power n is e, right? This is, we know already. So if I take limit n tends to infinity 1 plus 1 by 2n raised to the power 2n, that is also e, because here n is symbolic of a quantity that is moving to infinity and the same quantity whose power has to be raised, right? So if I convert it into this format, 2n, so if I can 2n raised to the power 1.5, that is possible, right? So from here you can see that it is what, e raised to the power 1.5. So it is existing. So yn is convergent. So this option and this option is already crossed out. So let us check about xn. So xn is the series. Okay, xn is so this quantity depends on n. So if n is odd, this is -1. If n is even, it is 1. So we can actually write xn, we can break it apart. So if n is odd, what happens? It is 1 minus of -1, that is 2. 2 plus 1 by n. If n is odd, if n is even, it is 1 by n only. If you see -1 raised to the power even number is 1, so 1 minus 1 is 0. So if I do limit x tends to, sir, not x, limit n tends to infinity, xn, it will be what? 1 by n will be 0, right? If n goes to infinity, so it will be 2 if n is odd, it is 0 if n is even. So limit is not existing because we are oscillating between two values, right? So limit is not existing, that is why xn will not be convergent, but yn is convergent. So option 4 will be our correct option, right? So question 5 is saying that a function is it's a real valued function from R to R such that the derivative of all order exists. So we have to see which option is false, right? Now if you think of such a function, there can be infinite functions, right? F of x is, sin x is also such a function whose all derivative exists. If you can differentiate this function n number of times. It can be cos x as well, it can be e raised to the power x as well, it can be log x. No, right? Because the domain of log is not a real number, so it is just the open 0 to infinity, so it is not a function. But yeah, we can combine this function or any other function. So there can be infinite function, even the polynomial function. If f of x is belonging to the vector space of the polynomial function, then also it is true. So we have not been given much information here, right? We have to see the option and we can eliminate from the option itself. So the first option is saying if f is a polynomial in x of degree at most 5, then the sixth derivative is 0. This is true, right? Because the maximum degree is 5. If you differentiate sixth time, okay, let me just give you an example. So if f of x is polynomial of first degree, so let us say a0 plus a1x, then the degree is 1. So let us do a second derivative. So f dash of x is a1, f2 of x is what? 0, right? So same thing. If the degree of the polynomial is m, then m plus 1th derivative has to be 0. So this is true. So it is asking which option is false. Okay. Now the next question is that next option is if the sixth derivative is 0, then f is a polynomial of x of degree at most 5. So a real valued function whose sixth derivative is 0 is a polynomial function. It is saying that. So is that true? That has to be true, right? Because if I take f of x as any function other than polynomial function, if I do sixth derivative, right, then I am doubtful that it will be 0 for every x belonging to R. That will not be possible. The only possibility is that if f is a polynomial of degree at most 5, so a0 plus a1x up to a5x raised to the power 5, then only its sixth degree will be 0 independent of x. Otherwise it will not be 0. It can be 0 at some points, but for every x it is not possible. If you want the exact method also, we can think like, yeah. So let us say f6 of x of such a function is 0. That means what? Derivative of this is 0, right? This I can write it is as this. That means f5 of x is nothing but a constant, because a constant derivative has to be 0, right? We know that we can solve a differential equation of a function whose derivative is 0. Then y will be a constant function. We can integrate, right? We can integrate. If I integrate like df5 of x, I can take integration both sides, it will be f5 of x. This is 0, but a constant term will come in integration, so it is c, right? Now I can write f5 of x as d by dx of f4 of x. Okay, now obviously, so if we do an integration, f4 of x will be kx plus some constant c. So if I go on that pattern, you can see that I have removed from f6 I have reached f4. So till from here I can actually go to f0. F0 is nothing but my function itself, right? So as you can see, I am getting polynomials only. So if I do one more step, f3 of x is integration of this thing. So integration of this thing is k x square by 2 plus cx plus c1, a new constant. So this is nothing but a polynomial. So if you go to f0 of x, it will be a fifth degree polynomial. So this is also true. Now from these two options, one has to be false. Let us see. If fk of a is 0 for all k and this is greater than 0 for some a, then fx has a local minimum at a. So it is saying that the kth derivative at a point is 0 for k from 1 to 5, but its sixth derivative is positive. That means f of x has a local minima at a, and it is saying the exact reverse thing, that if up to 6th is 0, the 7th is negative, then that means it has a local maximum. So it is basically your application of derivative question, right? If f of x is a function, any function, let me give you the concept. You can solve these two question, solve for this question, these two options without the concept as well. So can you think of such a function whose derivative is 0, not first derivative, not second derivative, but let's say third derivative, up to third derivative it is 0, but fourth is not 0. Obviously x cube, right? We have seen the f of x is equal to x cube function. F of x is x cube. Its first derivative at 0 is basically 0. Its second derivative is also 0, but its third derivative is non-zero, right? Similarly, if I take f of x is equal to x raised to the power 4, it is basically like that x square graph only, but with a heavy slope, right? Just I mean, if you draw f of x is equal to x square here, this is x to the power 4 obviously, but if I draw x raised to the power 2, x raised to the power 2 will be like this, because for given value, let's say if I take x is equal to 2, the 2 square will be less than 2 raised to the power 4, right? Obviously. So I mean, that is not useful here. I just gave you one concept here, but yeah. So here if I take first derivative, it is 0, second derivative 12x square 0, third derivative 24x 0, fourth derivative is non-zero, right? Fourth derivative is non-zero. Here it is saying sixth is non-zero. So if I draw the graph of f of x equal to x to the raised to the power 6, it looks exactly like that only. So if you have played with graphs, you know that f of x raised to the, is equal to x raised to the power some even number looks like that parabola only. So it is x raised to the power 10, then the lesser degree will be little bit wider, so x raised to the power 6, x raised to the power 4, x raised to the power 2, like that. So why I am doing this? From the pattern you can see, if I take f of x is equal to x raised to the power 4, its third derivative up to 3 it is 0, but up 4 is positive, right? So power 4, fourth derivative is positive, but previous derivatives are 0. Power 6, sixth derivative will be positive, but remaining will be 0. So this option is true, right? We saw it exactly, that f of I mean, if a, let us take a point as the x is equal to 0, so up to this it is 0, but sixth is positive obviously, then f of x will have a local minima at a. Definitely it has, right? So the correct option is option 4. So you can skip to question number 6 if you have understood this, but for the people who are more curious, I'll solve some more things. So here you can argue one thing. So for the people who are staying here right now, from here also you can argue one thing, that sir, this function can be any function. For option elimination, I need one function, one example to eliminate the option, but to prove that this option is true, I have to prove for every function. You have only shown for one such function, that is x raised to the power 6 or a parabolic type of function. You have not shown it for all the functions. Then how can you mark it as true? Right? How can I mark it as true? So that is a very good question. So for that we cannot solve question number 3. We have to eliminate option 4. Right? Because option 3 is true, so I cannot prove it by taking every example. That is why let us go to question 4. So question 4 is same thing. So f of x is equal to x cube. We saw the graph. Here we learned that f dash first derivative was 0, second derivative was 0, third derivative was positive. So if I take f of x is equal to x raised to the power 7, I mean you know the odd even theory, right? Odd even theory that I already told you. So if the power is odd, x raised to the power any odd power, then the graph looks like that only, x cube only. So if I do, I mean for here from 1 to 6 the derivative will be, order 1 to 6 derivative will be 0, 7th order derivative will be positive, but it is saying 7 should be negative, so I can do minus x raised to the power 7, right? It is the same graph, it will be flipped like this. I mean the accuracy is not like this. So f of x is equal to minus x raised to the power 7. So here this satisfies. So f k at 0, it is saying for some a belongs to R, so I can take any a. At 0 is 0, but at 7 it is negative. That means it is saying it has a local maxima. But we know that this functions like x cube or like that, odd power, they do not have a local maxima or local minima at x equal to 0. That is why these points are known as saddle point. So for this I pointed out a counter example, right? So I have a counter example that I can take a function whose derivative exists, obviously this function, but this is not true. So this is false directly. So that is also a way you can mark option 4 as a correct option. So the next question is question number 6. So question number 6 is again from sequence, and I'll not be solving anything in the bookish method way, because I personally is a fan of visualizations through graph and understanding mathematics through application, through real world problems. I actually try to not just see the equation, I just try to understand what the equation means in behind. That is why I directly explained the Rolle's theorem without even mentioning Rolle's theorem, right? Because I do not remember mathematics like that. So anyways, enough of that. So question number 6, it is saying we have been given two sequences, and based on that we have to do certain convergence or not. So there is a sequence and we have been asked about the convergence of series, right? Okay. So let us do an first, because based on that is the backbone of these two series. So an is a sequence of numbers, right? We are not given a positive series or negative series, alternating term series. It can be any arbitrary series. So an will have some positive terms and some negative terms, right? Bn series is formed by, if this thing is positive, then copy this thing in Bn, otherwise write 0 in place of that. So Bn is formed like that. So if we will take all the positive terms and we can write 0 for all the negative terms. That is the series Bn, etc. Right? Cn is the opposite series. Cn is saying that if I am finding negative numbers in the main series, then you can copy paste that negative number and write 0 in all those numbers in remaining places, right? We understood what the series is, right? Okay. Now option 4 is not true directly if you read it. Because what is the meaning of convergence? I'm not asking about the equation and limits and things like that. What is the meaning of convergence? If you can feel a series converging, I mean, if I write an as some random numbers, if I write an as a sequence of some random numbers, there can be positive numbers as well, there can be negative numbers as well. So the positive numbers, so let's say x, if I take a positive number a, p and a n, a capital N, if I take positive number out and negative number out and I write it like this, so sigma an is nothing but sigma ap plus sigma an, sum of positive number and negative number, obviously, right? So sigma ap is positive, sigma an is negative, so an, this negative numbers are cancelling positive numbers, and that is why the series is converging. That may be one reason that the series is converging, right? Because converging means what? Attaining a value. Sigma an is attaining a value. That is the meaning of convergence. If I have positive numbers only, then also I can attain a value. I know that sigma 1 by n square is pi square over 6. But sigma an is converging, right? So but if you see this, you can exactly catch that sigma bn is nothing but sigma ap, because bn is the positive terms that has been taken out of an, and cn is the negative term that has been taken out of what I can say, the an, obviously. So sigma bn is basically sigma ap, sigma cn is basically sigma an. Now it is saying if sigma an converges, that means these two has to converge. It is not necessary, right? Why? The convergence of this series, the reason of convergence is that, I mean, the reason of convergence may be that this itself is diverging, itself is getting a bigger value, but this is also getting a bigger value, and this is somehow cancelling the effect of that number getting big, and that is why the series is converging. That may be one reason, but that does not mean that these two individually will converge, right? So this option is false. Okay, if you have not understood this, so we know that sigma 1 over n is divergent. We know this, right? From the P rule of the convergence of series, the P test we know, right? But sigma of minus 1 raised to the power n by n is convergent. How this magic happened? If I write 1 by n, it looks like 1, 1 by 2, 1 by 3, up to anything and any value. Let me write some more terms and so on. But minus 1 power n by n is minus 1, 1 by 2, minus 1 by 3, 1 by 4, minus 1 by 5 and so on. So this series is diverging. That means this number add up to go to infinity. It is not going to a particular value, because if it had to go to a particular value, we would have known the value, right? But this looks like them, but it is converging because these numbers are the same numbers. They individually will go to a higher number. That is the meaning of divergence. But there are negative signs in between that is cancelling that increment. That is why this series is converging. That does not mean that this individual and this individual will converge. That does not mean that. Right? Because if I take these terms only, if I take AP only, it will be 1 by 2, 1 by 4, 1 by 6 and so on. It is nothing but 1 by 2, 1 plus 1 by 2. This is the original divergent series. So this is going to infinity. That is why it was divergent. So infinity multiplied by half is basically infinity only. So this is diverging. I again showed you a counter example by default. So this is false. We know that. Now it is saying sigma an does not converge, then bn does not converge. It is saying that if an is not converging, that means that these things, bn is what? Positive terms are not converging. There is a possibility that an is not converging, but this is converging, but due to an being very negative values, this is diverging. So I'll give you an example. So if I take an as, let's say, what let's say 1, okay, let us make AP converging. To give a counter example, I have to make AP converging and an not converging, and an, I mean this capital N, we can make it anything. So I gave you a feel already that this number is not converging, right? It can be due to the fact that this negative numbers are very high, so it is going to minus infinity. Not converging of a series means it can go to minus infinity or it can go to infinity. So it can go to, let's say an is basically, AP is basically is very small number. Let's say AP is 0, there are no positive terms. But an is, let's say, minus 1 by n. Okay, so if I write an, a small n, not capital N, my series is looking like what? My series is looking like minus 1 by 2. So there is no positive terms here. And we know that this is divergent, because if I take a minus sign common, that will be my usual series, right? 1 plus 1 by 2, and it is going to infinity. So an is not converging, but AP, because there is no positive term, so it is basically 0 plus infinite times 0, that is 0. So this might converge, right? So this is also wrong. Okay, second option, an converges, but mod an does not converge. That means bn converges. Okay, what does it means? Let me just erase it. We have to be very focused now to understand what it means. Okay, we know that sigma an is nothing but sigma AP, the sum of positive terms in that and sum of negative terms in that. I can indirectly say that it is basically sigma bn plus sigma cn. Now what is mod an? Mod an is nothing but all the positive terms, sum of all the positive terms, and sum of all the negative terms if we eradicate the negative sign. So it is basically the negative of sum of all negative terms. Right? That is mod an. Okay, now if we have this thing already clear, we can actually understand this question. So in these two options, this part is common. So let us understand what it means. So it is saying, okay, I'll use, okay, I do not have much slide here, but I'll use a small space here. Okay. So it is saying an is converging, but if I mean an converging means we are adding positive terms and the negative terms are cancelling some of the positive terms, right? So that is, this effect is resulting in a finite value, is what is the meaning of convergence. But if I take all the negative term and remove their negative sign, I make them positive, then this term is not converging. That is the meaning of this is not converging. So if an is, let's say, 1 minus 2 3 minus 4 5 minus 6, then mod an is basically all the negative terms, rather than cancelling these effects, they are adding up. So it is like 1 2 3 4 5 6 and so on, right? So mod an not converging means what? Means sigma bn and sigma cn's positive value, if I make it positive, because this will be a negative value, right? If I make them positive, this will diverge to infinity. Okay, let us understand the options. So if an is converging, mod an is not converging, that means sigma bn does not converge, and in second line it is saying sigma bn converges. Let me just erase this thing. Let me just give you the calculus point of view. let us say that the sum of positive terms is xp. I mean, we use the notation sigma ap. Okay, let's use that. Sum of negative terms is an. Let us say that absolute value of an is mod an, that is the positive part. Let's say if you add negative terms, it becomes minus 30. We are taking positive 30. That is the meaning of sigma mod. Sigma mod an is equal to sigma ap plus mod of sigma an, right? And sigma an was nothing but sigma ap plus sigma an. Okay, it is saying that this is not converging and this is converging. This is converging because this is a negative value and it is cancelling some positive part, right? It is asking about sigma bn, so it is asking about whether this is convergent or not convergent. So how do you think about this? So this is nothing but your sigma bn, right? I mean, the thing that is written here, that is nothing but your sigma bn. They are asking about sigma bn only. They are not interested in sigma cn. So it is basically sigma cn. They are not asking about that. So I have to eliminate sigma cn, right? So how can I eliminate sigma cn? Let's say sigma cn was minus x. I know that is negative, right? So in place of sigma cn, I can write minus x. And mod sigma cn is plus x. So I can add these two quantity, right? So sigma this thing by 2 is sigma bn. We know that this is diverging to infinity, but this is somehow converging. So this is infinity and this is some finite value. So what will be the result of infinity plus a finite value? So this will be infinity only. Infinity by 2 is infinity. So sigma bn will not converge, will never converge. So that is the solution of question 6. So question 7, guys. So what is question 7 saying? It has given us a function that is from closed 1 comma 9 to any real number, and f of 1 and f of 9 is same. So if this is 1, this is 9, this is f of 1 and this is f of 9, right? So my function will pass through these points, and from Rowe's theorem I know that if two values are equal, then I can get an alpha belonging between these two values such that f of alpha is 0, right? So alpha can be anywhere, here or here, anywhere. Now what is the meaning of two functions being equal? So it is saying that there exists c belonging to 1 to 5 such that f of c is equal to f of c plus 4. So if this is c, I mean 1 to 5 means 5 is the midpoint of it. So 1 to 5, if I take a c, then it is saying that we will get the exact same value at c plus 4 as well, right? What does this means? If f of c is equal to f of c plus 4, then I'll find a point beta, let's say, belonging to the gap, the difference between these two. So that is belonging to c to c plus 4 such that f dash of beta is 0, right? So if I translate all of these options, it is very simple, guys, to see. So if I translate these options, so it is saying we'll find a number. Let us use alpha notation only. If it is saying that if I will find a number alpha 1 such that f dash of alpha 1 will be 0 for alpha 1 belongs to c to c plus 4, but c is 1 comma 5, right? So it is saying alpha 1 will belong to, if I take c as 1, it will be 1 to 5. If I take c as 5, it will be 5 to 9. So indirectly it is saying alpha 1 will belong to 1 to 9. If I translate this option, it will be f dash of alpha 2, let's say, will be 0 such that for an alpha 2 that will be between c to c plus 1, and that means if I take the lower limit 4, it will be from 4 to 5, and if I take upper limit, it will be from 8 to 9. So it is saying that I will find an alpha 2 such that the slope at that point will be 0 and alpha 2 will belong to this, and I can translate all of these four options like that. But what we know for sure, that we will find an alpha, we'll find a number between 1 to 9 such that that derivative is 0, and out of all these four options, the first option is translating to what we know for sure. We know that alpha will be there between 1 to 9, and first option is indirectly saying that I'll find an alpha such that between 1 to 9 such that its derivative is 0. All other options are saying that I will find an alpha, a value. I can name alpha 1, 2, 3, anything. The name does not matter here. It is saying that we will find an alpha whose derivative is 0, and the alpha will be between these two, and it is not given explicitly. Yes, alpha can be between 4 to 5, it can be between 8 to 9. It is there, but we do not know for sure. Additional information is not given. So that it is saying necessarily true. The first option is necessarily true. Next question is question number 9. It is basically about the convergence of a series, right? So okay, we can rewrite the equation basically for this kind of question. 3x raised to the power k by 2 raised to the power under root k 1 minus x raised to the power k. If I write it, it will be k 1 to infinity 1 by 2 under root k 3x by 1 minus x raised to the power k. I want to make this series as convergent. So what will be the range of k for which this series will be convergent? That is the question, right? So okay, let me just teach you a concept. Basically, if you have known my pattern till now, I have not gone into academic depths. I am just giving you the feel of mathematics, right? So here, how can this series be convergent, guys? So if I remove this first line only, if I write only 1 here, let me just write the series that will form. It will be 1 by 2 plus 2 root 2, 2 root 3. This series, guys, what do you know about this series? This will be convergent, right? I know that 1 by an exponential term is always convergent. If you know this, you know this. 1 by an exponentially growing number will be convergent anyways. That is guaranteed. You can prove it by what we say. This is a theorem, right? When we study positive term series, because this is positive term series, there is, I guess, Cauchy's test. That is, if sigma an is convergent, it says that sigma 2 raised to the power n, a 2 raised to the power n is convergent. This is Cauchy condensation test. You can prove every exponential series as convergent using this test as well, but yeah, we are not going to go that. For reference, I'll not erase it, right? So okay, so any exponential thing is fine right here, but this quantity can hinder that exponentiation. Let me explain what I am saying. So the given sequence, the given series is 3x by 1 minus x raised to the power k by 2 raised to the under root k, right? Let us say the inner quantity. This can be anything, right? This can be any value that depends on x. So let's say this, I rename this as a. So it is sigma k 1 to infinity a power k 2 under root k. If a is root 2, let's say if a is root 2, okay, just a minute. Okay, if a is somehow not root 2, just let me see the question. It is under root k, and okay, Okay, 2 under root k. So if a is 2 somehow, then 2 power k by 2 under root k, it is 2 by k minus under root k. It is a direct exponential series. It is not 1 by exponent, so it is increasing like exponent, right? So if anything that will increase like exponent, if we add some larger terms, if we add positive terms that are growing like hell, then obviously the series will not be convergent, it will diverge to infinity. That is the basic meaning of convergence and not convergent, right? So if I take a as 1 point, any number 1.5 or even, then 1.5 raised to the power k and 2 raised to the power under root k, this term will be very larger if k goes higher. Even if I take k as 5, 1.5 multiplied by 5 times and 2 raised to the power under root 5. Here there is a under root, so under root 5 means what, 2.23, so 2 into 2 into 2 raised to the power 0. 23, so 23. So we can see that this quantity is higher for smaller k. If I take larger case, it will be even higher. So higher terms adding up, that means series will be divergent, right? So here there is an under root k, that is why this problem is happening. Here there is under root k, that is why if you take any number that is just greater than 1, 1.1 even, then also this thing will be greater than 1. It will not converge to 0. For the series to be convergent, this quantity will converge to 0, right? And this quantity will converge to 0 only if the inner thing is less than 1 or equal to 1. Then only 1 by 2 power k or 0.5 by k 2 power k, because this is anyhow will be going to 0, right? So this is not adding a meaning to this original series, right? So that is why this series will always be convergent. So you can actually do one thing. You can actually do limit this thing x tends to infinity. You can find the limit of this term and you can equate it to 0 and then find for what value of x the limit of this term is getting 0, because that is the first test for convergence of a series, and from there you can find the answer. But what I am saying is that if this series is less than or equal to 1, this term, then it will converge, because then and only then the term will not blow up, right? So you can actually do one thing. If this is in less than equal to 1, greater than equal to -1, that is the meaning of less than equal to 1. The magnitude, basically the sign does not matter here, because obviously the numbers are very smaller. So if I add a negative sign as well, nothing matters here. So if I solve this equation, now in all of these options, one thing is that x is always less than 1, right? So this term, for sure we know that this term will be positive. We can solve it and then know, that is a different thing. But from options, that is one thing is clear, that x is belonging to this set, and for this set x is less than 1 already, right? So this term will be positive already, so I can directly multiply it without worrying about signs. So yeah, so if I solve it in two parts, it will be 4x is less than equal to 1 and 3x is greater than equal to, 2x is greater than equal to 1. So x is greater than equal to half, x is less than equal to 1 by 4. It is -1, so -half and 1 by 4. So it is option 3 that is correct directly. So I tried to explain this question intuitively. You can actually solve this question by this approach that I already told you, that take the term and equate limit to 0 and you will find the value of x. But yeah, that is a lengthy process, that is why I solved it intuitively. Okay, welcome to question 11. So after question 9 we have jumped to question 11. Question 10 we'll solve it after a while. Okay, so question 11 says, which one of the following statement is false given a function, whether f is continuous or not. We can find this by standard rules, right? Okay, let us first try a simple thing, that is df by this thing or this thing. So df by dx by definition at 0, 1, it is basically limit h tends to 0, f of h comma 1 minus f of 0 comma 1 by h. This is dx at 0 comma 1. So it is limit h tends to 0. Okay, so f of h comma 1 is 5h square minus 4 by h square plus 1 square, that is h square plus 1 minus f of 0 comma 1. So if I put 0 in place of x and 1 in place of y, I can see that 0 minus 4, it will be minus 4 only, so it is plus 4 by h. So it is limit h tends to 0. 5h square plus 4h square is a 9h square, minus 4 plus 4 is 0 by h cube plus h. So it is limit h tends to 0, 9h by h square plus 1, right? Now if h is tending to 0, this quantity will tend to 1 and this quantity will tend to 0, that means this thing will tend to 0. So option 3 is correct. So it is not our answer as of now, because it is asking which option is false. If I solve df by dy at 0 comma 1, it is nothing but limit value of limit h tends to 0 f of 0 1 plus h. Okay, it is asking at 1 comma 0, so 1 comma h minus f of 1 0 divided by h. Simple definition, right? Limit h tends to 0, f of 1 comma h is what, 5 into 1 square into h, so 5h minus 4h cube, 5h minus 4h cube by 1 plus h square minus f of 1 comma 0, put 0 in place of y, it is basically 0 only, by h, you can see. So if I put 0 in place of y, so this terms is containing y, this y, so it will become 0 only. So limit h tends to 0, 5, if I take h common here, 5 minus 4h square, h into 1 plus h square. If I put h as 0 now, it will be 5. So this is also true. Now option 2, let us find f is continuous at 0 comma 0 or not. F is continuous at 0 comma 0, that means limit x comma y tends to 0 comma 0, f of xy exists, right? So we can do it by putting y equal to mx and then we know how to do it, but that is not the foolproof method. The foolproof method for this kind of question, if a function is a two variable function and you are finding at 0 comma 0, then you have to turn the function in the polar coordinate form. That is the absolute solution to this question. Even though you can do mx in place of y and then find limit x tends to 0, f of x comma mx, even if this limit exists, then also it is not guaranteed that your function is continuous. So that is why for 0 comma 0 we use polar coordinate form. That is the absolute method, but here I do not want to use it because I can immediately look at this. Okay, for this also I have to do it 0 comma 0. So basically let's start doing that. Let's start using polar coordinate. So f of xy, okay, so it is basically equal to limit x comma y tend to 0 comma 0 f of xy. If this exists, then we say that limit exists. So basically limit, we can do r tends to 0 in the polar form f of r theta, right, where x is equal to r cos theta and y equal to r sin theta. So limit r tends to 0, let us put x as r cos theta, so 5 r square cos theta, cos square theta basically, into r sin theta minus 4y cube, so 4r cube sin cube theta divided by the denominator, x square plus y square is basically r square, right? So limit r tends to 0, r cube can be taken common from numerator, so 5 cos square theta sin theta minus 4 sin cube theta by r square is equal to limit r tends to 0. Okay, I can cancel it, right? So if I take limit r tends to 0, because r is already there in numerator, the limit will be 0 only. Why? It is independent of theta. from any direction you can come. That is the benefit of polar coordinate. If I take y equal to mx direction, I am coming at 0, 0 from a straight line direction only. I am not coming from a parabolic direction. So limit existing means you, from whatever direction you come, the value should be the same. You will get the exact same value. That is the meaning of limit. That is why we are using polar coordinate here, because polar coordinate is independent of direction, independent of theta basically. So I mean, polar coordinate takes into account r and theta. Theta means direction. So here you are seeing that if I am doing limit r tends to 0, this entire thing is turning to be 0. It is independent of theta, that means the direction from where you are coming. So f is continuous at 0, 0. So this is my correct option. So we can check the fourth option as well, right? Df by dy is continuous. So for that, let us do one thing. Let us do d del f by del y. Let us find out the value. I mean, if it is true, then we know fourth will be true, but for the sake of finding out, let us find out. So 4y cube by x square plus y square, it was my question, right? So df by dy is, I can take the partial derivative directly. If I take a square, the derivative of upper term 5x 10xy minus 12y square x square plus y square minus okay, it is getting bigger, so I do not have to solve this for now. We saw that, I mean, the function being continuous is that the limit exists, and the limit, whatever the limit you found, must be equal to this thing, must be equal to f of 0, 0. That is the meaning of function being continuous. And we saw that the limit is actually 0 here. Let me just confirm it once. R sin theta and r square we are getting, right? So yeah, it is continuous. So this option is true. So the only false thing is this. Okay, so next question is question number 12. Question number 12 is a very easy question. It is the start of MSQ. So up to question number 10 we had, up to question number 11 we had MCQ type question, and from now on we'll be having MSQ and then numerical answer type questions. So what is the meaning of differentiability first? Differentiability means for a one variable function, it means LHD should be equal to RHD, left hand derivative at a point. So for here it is derivative, f of 1 minus h minus f of 1 by h, limit h tends to 0. It is my left hand derivative, and right hand derivative is what? Limit h tends to 0, f of 1 plus h minus f of 1 by h. This two quantities should be 0, but we do not have to worry about these two things, because if you have followed the video entirely, I have told you how to solve this question without actually solving it. So basically let us talk about GIF functions. GIF is basically, if you know the graph, it is not continuous at integers. GIF is not continuous at integers, because GIF x is 0 for points from 0 to 1, but at exactly 1 the GIF becomes 1. Then it remains same for any quantity that is belonging to 1 to 2, but at exact 2 it becomes 2. So at 1 it is not continuous at all. So how can it be differentiable? Differentiability should imply continuity. If the function is not continuous, it is not differentiable. First point of check. So this is incorrect. Talking about this x square minus 1. Now x square minus 1, we know that the graph of x square is this. X square minus 1's graph is, if I bring it 1 unit bottom. So if I bring 1 unit bottom, let's say this is minus 1, 0 comma minus 1. This is x square minus 1. So x square minus 1 intersects the x-axis at what points? How to know that? Equate it to 0. So x is plus minus 1. So it is minus 1 comma 0. It is plus 1 comma 0. Right? If I take mod of x square minus 1, mod means take the negative part. What is the meaning of mod? If I am getting a negative value in the original function, I have to return positive. So for the negative part, I have to return positive. So the graph of mod of x square minus 1 will be like this. It will not have the bottom part. It will not have the bottom part at all. So the graph of mod of x square minus 1 is like this. Like this. And this is 0.1 comma 0. This is point minus 1 comma 0. So as you can see that at x equal to 1, that means at this point, I am encountering a sharp edge. And we know that the function is not differentiable if I encounter a sharp edge. Because from the left hand side, if I take derivative, the slope of the point becomes this, right? Slope is positive from the right hand side. But from the left hand side, if I'm coming at this point, the slope is negative. So that is why the function is not differentiable. In sharp edge, that is the problem that happens. From both of the sides, you get two different values. So it is not differentiable. And you can actually solve it by this method entirely, but because this is exam setting and I do not, if there is a method available, very good method, I mean I solve it like this. So incorrect about these two things. I mean, this is, you can see, you can directly do f dash of x for this part, for mod x less than equal to 1, f dash of x is, okay, let me just do question number, option number 4 first. F of x is equal to mod of x minus 1's whole cube, right? I mean, we cannot draw a graph here. Actually we can, but let us think, let us solve it by that method as well. So left hand derivative means the derivative of the function if x is less than 1. Right hand derivative means the derivative of the function, that is if x is greater than 1, right? So we know that if I write this function, f of x is equal to x minus 1's cube, x minus 1 cube, if mod of x minus 1 cube is positive, and mod of x minus 1 cube will be positive if x is greater than equal to 1, obviously, right? And it is minus x minus 1 cube if x is less than 1. So if I take derivative directly, I can see it is 3x minus 1 square, it is minus 3x minus 1 square. So in the left part of the function, left part to 1, I am getting the derivative as 0. In the right part of the function, I am getting the derivative as 0. So left hand derivative is equal to right hand derivative, right? So this function is differentiable, obviously. Similarly, I can do for option 1. So for option 1, I have left part of the function. For mod x greater than 1, I have a definition, that is for x belonging to 1 to infinity, I have a definition. For x in between minus 1 to 1, I have a definition. So basically, for the left part, I can use this function. For the right side of the 1, I can use this function. So f dash of x is basically 0 for the right part, and for the left part, I can actually take the derivative 2x e power minus x square minus 2x cube, basically e raised to the power minus x square. So if I put x is equal to 1, right, I can see that this is getting 0 as well. So this is also differentiable. So the correct answer to this problem is option 1 and 4. Now this question is also simple, right? For a function to have a local minima at x equal to 0, f dash of x should be 0, right? And f double dash of x is positive. I mean, I'm talking about the first option. We can use this trick in the first option. So f dash of x, if I find cos x plus 3x square by 6, that is x square by 2, f dash of 0 is coming out to be 1. So at x equal to 0, there is no minima or no maxima. So first option ruled out. For sin x, I can do f dash of x. Sin of mod x basically is basically the derivative of sin. So cos mod x, and derivative of mod x is x by mod x, right? So at x equal to 0, what happens? Okay, so this is basically little confusing. So let me just rewrite the exact thing. F of x is sin x if x is positive, minus sin x if x is negative. So if I do the derivative for the right part of 1, it is cos x, x is greater than 0, minus cos x, x is less than 0. So basically yeah, so f dash of 0 is 1 minus, so the derivative is first of all not existing. I mean, function is not differentiable, but is it continuous? I mean, you can see from here that function is not differentiable. That does not mean that it cannot have a minima or maxima. Minima maxima is basically the meaning of having minima or maxima is that if, what does this means? If x equal to 0, if function is having a minima, then the nearby point value should be higher than this point. Let us try for this function once using this definition. F of x is equal to sin x. So f of 0 is what? Sin 0, 0. So if f of h is a very small positive value, and f of minus h, where h is also a very small positive value. So this is x equal to 0. I am talking about all these nearby left value and all these nearby right value. If those values are positive, that means this is the point of local minima. So f of h is basically sin mod h, and it is sine of minus mod h, that is sin mod h only, and sine of mod h is positive, we know. So sin h, and sin h, where h is just greater than 0, it is nearby 0, is positive, we know that. So this is a point of local minima already. Now third option is f of x is min of x minus gif, 1 minus x plus gif. So similar logic we can follow. We can draw graph as well, but there is no need of graph drawing. So f of, what is the value of at f of 0? Minimum of 0 minus 0 and minimum of so minimum of 0 and 1, so it is 0, right? Now I have to find f of h. What is h? H is a very small positive value. Is minimum of h minus gif h. Gif h will be 0, right? Because h is a very small positive value, like 0.001 or something. Its gif is 0, obviously. So h minus 0 is okay, 1 minus h plus 0. So that is I can directly write it. So minimum of h and 1 minus h. Now h is a very small positive number. So it is, if it is 0.01, then it is 0.99. So minimum will be h only, right? So this is h. If I take f of minus h, that is the left side of 0, where h is now, h is also positive, very small positive number, it will be minimum of minus h minus this plus h plus minus h. Now if h is very small positive number, minus h is a very small negative number, so its GIF is minus 1. I know GIF of minus 0.001, GIF means greatest integer function, so it is minus 1 only, right? So I can minus h, minus of minus 1 is plus 1, comma, this is h, right? Because this is minus 1, so it can cancel this thing, and it is the same thing as this, so the answer is h. So f of h and f of minus h both are positive numbers, which is greater than f of 0. So that means this is local minima only. That is the definition. By definition we can show that, right? And similarly we can do for question 4. F of x is x4 plus x square plus 3, I guess. Let me just see. Yeah. So f of 0 is basically 3. F of h is basically h power 4 plus h square plus 3. F of minus h is nothing but h power 4, because negative power 4 is the same as positive power 4, negative power 2 is same as positive power 2, and these two numbers are greater than 3, because if I take h as positive, h power 4 is positive, this is positive, so this is greater than 3, so this is the point of local minima. So 2, 3, 4 options are correct here. Right. Question number 14 is a very interesting question. It is on the Riemann integral, and what is Riemann integral? We'll look into it as well. So it is saying that f of x is cos x, for x being a rational number. So if I draw a cos x graph looks like this, right? Now x belongs to rational number. This graph is becoming 0. That means there are infinite rational numbers here. So the graph is becoming 0 infinitely many times. If I take any interval from here to here or here to here, the graph is becoming 0 infinitely many times. And cos x is not 0, right? Cos x can be any value between -1 and 1. So this basically, from the definition, if you see, it is not Riemann integrable. You have seen a function like this, right? 1 x belongs to rational number, 0 x does not belong to rational number. This function you have studied. I mean, in Riemann integrable function, we studied this function is one of the examples. And this function, a function is not Riemann integrable, that means it is having hell lot of discontinuities in many points. If it were to be this function, f of x is equal to 0 for x being rational and x does not being rational, then it would have been a Riemann integrable function. But if a function has lots of discontinuities, it is not Riemann integrable. If a function has infinitely many discontinuities in its domain, then it is not a Riemann integrable function. And we can see that there are infinite discontinuities, because cos x can be any value and it is suddenly dropping to be 0 in integer. In rational number, it is again dropping to be 0. So there are lots of discontinuities in this graph if you are attempting to draw this graph. So I mean, this point may not exist, it can be 0. This point may not exist, it will be 0. But an intermediate point might exist, it is upwards. So there are lots of discontinuities. So these two options are by default eradicated. Now it is saying f is continuous at pi by 2 or at 0. So f is continuous at pi by 2 or 0. That means you have to find limit x tends to 0 f of x, and you have to equate it with f of 0. So f of 0 is basically 0 because 0 is a rational number, and limit x tends to 0 f of x is what? Limit x tends to f of x is basically if I am, this is 0, if I am approaching 0 from right side, I am encountering many irrational numbers. Maybe a number that is very close to 0 in the right hand side is an irrational number. Yeah, you know that between any two rational numbers there is an irrational number. There has to be an irrational number. That is the extension of the Archimedean principle. So the very next number next to 0 might be rational, right? So for irrational, the definition is cos x. So what is cos 0? Cos 0 is 1. So it is by default not equal. So limit is first of all not existing, or even if it exists, it is not equal to 0. So f is not continuous at 0. So only statement that is true is this, because f of pi by 2, because pi by 2 is an irrational number, right? So f of pi by 2 is 0, because if irrational number is there, I'll take the definition of cos x, so it will be 0, and limit x tends to pi by 2 f of x. So if I am approaching pi by 2 from left and right hand side, so I might encounter lots of rational numbers as well. So if the very next number to pi by 2 is a rational number, then also that value is 0, because let's say f of pi by 2 plus is a next real number to pi by 2 in the right side. Let's say this is an irrational number. Then I'll follow the definition of irrational number to find out the value of f of pi by 2 plus. So it will be 0 only. Similarly, f of pi by 2 minus will be 0 only. If the next number if pi by 2 plus is, let's say, a rational number, then f of pi by 2 plus is rational number definition is again cos of pi by 2 plus. Cos of pi by 2 plus is 0 only, because a number that is very near to pi by 2, cos pi by 2, so that is 0 only. So this is basically equal. So option 4 is correct answer. Question number 15 is basically we have to find out whether it is continuous, whether it's differentiable, things like that. Let us start from this first option. So limit xy tends to 0 0 f xy by under root of x square plus y square okay, is equal to limit x comma y tends to 0 comma 0. F of xy is basically x square y by 1 plus x square plus y square sine 1 by x. If I take y as mx, limit m tends to 0, sorry, x tends to 0, mx cube sine 1 by x 1 plus x square and m square x square, so I can take mod x outside, 1 plus m square. If I put x as 0, I know that, I mean, let's take it as x only. So if I put x as 0, what happens? So if I take x cube by x cube plus 1, right? So this multiplied by m sine 1 by x 1 plus okay, x cube by x, it is 1 plus m square. Now you can see that this quantity, if I cancel things out here, x square by what, x square plus 1, this quantity is getting 0, right? So limit is existing at this point. And to be more correct, because I already told you in one of the question before that if you were to find the limit at 0 comma 0, y equal to mx is not a foolproof method. The foolproof method is you convert it into a polar coordinate format. But I used it because if you are doing y equal to mx and it is coming out to be limit does not exist, then you can eliminate it by using this. But to prove this, I mean, just like we use counter examples, counter example is needed to disprove something, but you need to prove something, that you need to prove it for every value. So that is the absolute method. So for this absolute method we will need, what we say, the polar coordinate. So okay, let us do limit this thing. So for polar coordinate it will be limit this f of r comma theta, x is r cos theta and y is r sin theta. So it is basically under root of r square, that is r. So limit r tends to 0, do r cos theta in place of x, so r square cos square theta sine 1 by r cos theta divided by 1 plus, okay, there is a y as well, so r sin theta is also there. So let me just take that into account, r sin theta. So r cube cos square theta sin theta sine 1 by r cos theta. Now there is 1 by x square, so 1 plus r square cos square theta, and there is r as well because we had r here. So limit r tends to 0, I can cancel 1 r or r square it will be. So limit r tends to 0, r square by 1 plus r square cos square theta into cos square theta sine 1 by r cos theta. If r is tending to 0, this thing is tending to 0 and this thing is tending to 1. So 0 by 1 is 0, so this thing is tending to 0. So no matter what it is, I mean, this is a bounded function, that definitely. So bounded function multiplied by 0 is basically 0. So this thing is 0. So basically limit is existing. So this option is wrong. Now the second option, we need to do this. So that is why let us use this space as well. So for the second question, okay, let us first find out limit x tends to 0 f of xy. So if I am tending x to 0, so 0 square into y by 1 plus 0 square, that is 1 into sine 1 by 0 So this is a bounded function. We don't know the value of sine infinity, but it is a bounded function multiplied by 0. So it is basically 0 only. So limit x tends to 0, f of xy is 0 only. It is not dependent on y. So this is 0. So limit y tends to 0 and something 0. I mean, this thing is 0 already, right? Is equal to 0 only. So it exists definitely. So this option is correct. Now we have to find df upon dy is continuous at point that or not, or df upon dx is continuous at that point or not. So for that, let us do that, right? I have to check for every option, MSQ question, right? So x square y by 1 plus x square sine 1 by x, and df upon dy, let us do that. So it is equal to f of x. So df upon dy, let us find out the derivative, partial derivative. So first of all, this term into derivative of second term. So it is basically x square y by 1 plus x square into derivative of sine 1 by x is 0, plus, because it is independent of y, plus sine 1 by x into derivative of this term. So 1 plus x square into upper term's derivative with respect to y multiplied by denominator minus denominator's derivative with respect to y is 0 basically. So if you this is basically this, if I can cancel this out, so it becomes x square sine 1 by x. So is df by dy continuous at 0 comma 1? Sorry, 0 comma 1. Yes, it is continuous at 0 comma 1. So obviously it is continuous, right? Because y is not there, so forget about 1. So if I put 0 here, I know that x square sine 1 by x function is continuous about 0, right? So there is a general rule, x power m sine 1 by x power n. If m is greater than n, then this function is continuous at 0. You can actually prove it. So this is continuous already. About option D, we can see. We do not have space much. Okay, so let us utilize this space. Question 4, option 4. Okay, let us do partial derivative with respect to x. So sine 1 by x derivative is cos 1 by x minus 1 by x square, and the second term x square y by 1 plus x square, plus second term constant, first term's derivative, so 1 plus x square, derivative of x square y is 2xy 1 plus x square, minus x square y into derivative of 1 plus x square is 2x. Now if I write it, it is, I can cancel this thing out. So minus y 1 plus x square cos 1 by x. If I take this thing, if I expand the numerator, it is 2xy plus 2x cube y minus 2x cube y. So this thing will cancel, get cancelled out. It will be sine 1 by x into 2xy by 1 plus x square. Is this continuous about 0 comma 1? Okay, we can take the denominator as if I demark this reason. So this is equal to 1 plus x square 2xy sine 1 by x minus y cos 1 by x. I know that this is continuous at 0 comma 1. At 0 comma 1 means it is depending on x only. So at 0, this parabolic function we know it is continuous. We only need to worry about the upper function. So at 0 comma 1, let us find the value, what the value is at 0 comma 1. So 2 into 0 into 1 into sine infinity minus y is 1 and cos 1 by 0 cos infinity. So 2 into 0 into 1, it is becoming 0 because this was 0, right? Into sine infinity is a bounded function, right? Sin x, so it is becoming 0 and it is becoming minus cos infinity, and we don't know the value of cos infinity. So that is why it is not continuous, because we do not know the value of cos infinity. It can be any value between minus 1 and 1. So this function, that is why it's not continuous. So it will get eliminated. So that is how you solve question number 15. Okay, now we'll solve question number 16. So question number 16 is about sequence, whether it will be converging or will have a convergent subsequence like that. So, and all these options, as you can see, there is a language that is there exist. So we have to think about a sequence. because it is not true for all. If it had to be true for all, then option would have been different, and we could have thought of a counter example and could have eliminated the option. But here there exists symbolizes that we have to think about the kind of series that is possible. So let us first start with option 4. Option 4 is saying that there exists a monotone sequence that does not converge but has a convergent subsequence. So a monotone sequence that does not converge, that means the sequence goes till infinity, right? We start from certain finite numbers, let's say 1, 2, okay, my pen is malfunctioning, just a minute. 1, 2, 3, I mean you start from any number 1, 2, 3, but finally eventually the number will be very, very large, right? There is the meaning of monotone and not converging. But it is saying, can it have a convergent subsequence? What is the meaning of subsequence? If I have series x1, x2, x3, x10 till infinity, then subsequences you have to pick numbers. You can pick this number, and you have to pick numbers after this number and after this number. So you have to pick in an increasing order of numbers. I am saying about increasing index order. So I am picking the element at second index. I have to pick next element from the index that is greater than 2. So I can pick, let's say 3, next I can pick 7, I can pick 10, so like that. So if you are picking, you have to pick till infinity. That is the meaning of subsequence. So finally we are going till infinity, and we know that this sequence is going towards infinity at larger indexes. So that means you will whatever subsequence you take, you have to go till infinite index, I mean, and at infinite index the number is infinity, I know. So that means the sequence is not convergent. I mean the subsequence even cannot converge, right? So this is false. Option 3, there exists a sequence that has a bounded subsequence but does not have any convergent subsequence. I mean similarly as option 4, if there is a sequence but its subsequence is convergent, that means all the number you picked, all the final numbers that you picked somehow is converging to a value, right? So you can say -1 reached number n. This series has a convergent subsequence. If I pick even indexes, then it is a convergent sequence. I mean, sorry. I actually misread this thing. So it is saying that there exists a sequence that has a bounded subsequence. So the subsequence that you are picking is bounded, but it should not have any convergent subsequence, right? I mean, let's take about the bounded subsequence you found. Bounded subsequence. So the bounded subsequence that you found is bounded between two values, let's say small m and capital M. It is bounded between these two values, right? Now if it is bounded between two values, that you can take the peaks, or you can take the minima, and you can find another subsequence which is actually converging to a particular value, right? So it is also incorrect, because I mean a sequence is a combination of its subsequences. I know that there is a given subsequence that is bounded. I am not commenting about the other subsequences that will add to this sequence to form that main sequence. I am not commenting on that. I am commenting on this bounded subsequence that is given to me. A subsequence that is bounded is oscillating. Either it is monotonic or it is oscillating. If it is monotonic, that means it is going from one value to another, and it is bounded, then that means this subsequence will converge. But right, so this bounded subsequence is convergent if it is monotonic. But if it is not monotonic, that means it is oscillating. If it is oscillating between two values, let's say small m and capital M, that means it is taking the value capital M infinitely many times and small m infinitely many times. So I can take those points where it is taking small m as a value. That will also be a subsequence because it is going infinite times, right? And for the rule of subsequence, I know, I told you I have to pick the numbers, this number till infinity, and yeah, there is availability of such numbers till infinity, so I can find out a subsequence. Next, option 2, there exists a sequence such that their difference is converging to 0 but xn does not converge. So a sequence is convergent, that means limit n tends to infinity xn exists, right, and is finite. Now it is saying that limit n tends to infinity xn plus 1 minus xn is 0, that means limit x tends to infinity, n tends to infinity, sorry, xn plus 1 is equal to xn. Here you can think like, if limit is existing, that means the final terms are almost the same if I move one index above or below. So yes, this means that the sequence is convergent, right? So this option is false, but it is not like that. Now these two things, if they are equal and they are finite value, let's say k, then that means limit is convergent, because these two values are almost same and that they are same as a value, that means they are convergent. But it might happen that these two values are same but they are of infinite types, they are infinities. Let's say for example square root of n and square root of n plus 1. Limit n tends to infinity, square root n plus 1 minus square root n is 0. But is this converging? Is limit n tends to infinity, square root n converges? No, right? It is getting infinite. But this limit is 0. I can prove it. I can remove mod because under root n plus 1 is greater than under root n. So the number is always positive. If I just rationalize this, it will be 1 by under root n plus 1 plus under root n. I know that this is infinity and this is 1, so this is 0. So I have given you a counter example. So there exists a sequence. The sequence is basically under root n only, or you can do a log n as well, that will also will have the same behavior, but it does not converge, it does exist, right? Now option 1 is saying there exists a sequence xn such that given any positive integer m, xn has a subsequence converging to m. Okay, I'll have let's say I make a sequence xn. Now I'll have a page, right? Xn is equal to 1 2 3 up to m. I'm going up to m, then again I'm doing up to m, I'm repeating like that. So if someone is asking you to find a subsequence that is converging to m, I'll pick this and I have the availability of this number till infinity. So this subsequence is converging to m. If m is 3, then I'll pick this, right? So there will exist a sequence like that. So question number 16 is done. Let us move to question number 17, the radius of convergence of this series. So let us expand this once. N is equal to 1 to infinity. N factorial square is basically n factorial. N factorial, it is 2n factorial. So 2n, 1 by log n xn. Now I have to find the value of x. That is the meaning of radius of convergence. I mean, this x raised to the power n can be between which value. So this x can be between which values. Or in other word, we can do one thing. We can use a ratio test as well. We can use a ratio test. I know that for a series to converge, an plus 1 by an must be less than 1, right? So I can actually calculate this n plus 1 factorial square by n factorial square by 2 of n plus 1 factorial, 2n factorial by 2n plus 1, that is 2n plus 2 factorial, and that is log e n, log e n plus 1, and x n plus 1 by xn, so it is x only. So this has to be less than 1. So I have to solve for this as n tends to infinity. So limit n tends to infinity. So n plus 1 factorial square, so I can actually break it down, right? So it is n plus 1 by n factorial square, right? And this is basically equal to n plus 1 into n factorial by n factorial square. So it is basically n plus 1 square. So I can write the first term. First term is limit n tends to infinity n plus 1 whole square. Second term I can write it is 2n factorial by 2n plus 2, 2n plus 1 into 2n factorial. So I can actually cancel it out and I can write it as 1 by 2n plus 2 into 2n plus 1. And log e, yeah, I can just write it as it is less than, it should be less than 1, right? Now I know that this limit is 1 because I just now I told you that log, as n tends to infinity, log n and log n plus 1 takes the same value. So if they are taking the same value, their ratio is 1. I already told you in this example that you can, just like under root n and under root n plus 1 is same as n goes to infinity, that is why they are becoming 0. Similarly you can prove it for log n, just like we proved it for this thing. So if they are the same, then it is getting 1. So it is limit n tends to infinity n plus 1 square, n square plus 2n plus 1, 4n square plus 6n plus 2 into x should be less than 1. Now I know that limit n tends to infinity, this thing, this quantity is basically 1 upon 4. We take the highest power coefficients ratio, right? So x by 4 is less than 1. That means limit n tends, so now there is no n, right? So that means x by 4 is less than 1. That means x should be less than 4. So the radius of convergence is 4. Question number 18 is a simple question. We can actually calculate it. So limit x tends to 0, x sin x minus x plus e1 minus cos x by x. I know that I have seen certain this kind of expression in my, while studying about limits, right? So this limit will exist separately. So that is why I can split this quantity and this quantity right now, because these are two different things. Limit x tends to 0, and we can split that limit of f of x tends to, let's say, t, f of x plus g of x. We can split it into limit x tends to t f of x plus limit x tends to t g of x, given that these two limits are not going to infinity. And I am pretty sure that I know that it will not go to infinity, and I know that it will not go to infinity, because if it will go to infinity, because one thing I know for sure, that this is not going to infinity, right? So this, if this goes to infinity, that means we will have an infinite answer, but there is some answer that means this is not going to infinity, right? I know that for sure. That is why I can split it into 2. So sin x minus x by x sin x plus e raised to the power limit x tends to 0, 1 minus cos x by x. We know that limit x tends to t e raised to the power f of x is basically e raised to the power limit x tends to t f of x, because x going to t has nothing to do with e. It will decide the value of this only. So we will find the value of this only, right? So limit x tends to 0, 1 minus cos x by x is how much? We can use the L'Hopital rule, right? So we can take the derivative. So limit x tends to 0, sin x by 1, right? 1 minus cos x derivative is sin x, so 1, so it is basically 0. So this is e raised to the power 0. Now this derivative, we can again use that thing, sin x minus x. So limit x tends to 0, sin x minus x by what? X sin x. So it is going to it is of 0 by 0 form. We can use the L'Hopital rule again by taking the derivative. So cos x minus 1 by x cos x plus sin x, right? Now again it is of the form 0 by 0. If I take x as 0, so it is 1 minus 1 0, it is 0 plus 0 0. So again we have to take the derivative. So limit x tends to 0, so minus sin x by minus x sin x, right? Now plus cos x, so 2 cos x. If I take this now, if I put x as 0 now, then it is coming out to be 0. I mean directly, because denominator is 2, numerator is 0, so I do not have to apply that again. So if I, so the answer is basically 1. Question number 19, it's a very simple question. You have to find the derivative at that point. So I can write z as cos, it is given this thing, but I have to find dz by d theta. So I have to write z as a function of theta, and now here I have given x and y in terms of theta only. So cos 4x is basically 2 pi plus 8 theta plus 5 times minus pi by 4 plus theta, right? So cos 2 pi plus 8 theta is how much? I mean, we don't need to calculate the value. 3 pi by 4 plus 3 theta, right? So dz by d theta I can directly calculate. It is first of all minus sine 3 pi by 4 plus 3 theta, then derivative of theta, I mean the derivative of inner quantity with respect to theta is basically 3. Now this is the derivative, and if I substitute theta as pi by 4, dz by d theta will be how much? Minus sine 3 pi by 4 plus pi by 4 into 3, so it is basically 4 pi by 4, that is sine pi. If I put okay, at theta is pi by 4, it is 3 pi by 4 because 3 theta is there. So minus 6 pi by 4, that is minus sine 3 pi by 2 into 3. I know this thing is minus 1, so minus of minus 1 is plus 1 into 3 is 3. So now it is a turn of question 20. So question 20 is basically you have to find the partial derivative with respect to x first and then with respect to y first at 0, 0. Now we know that, I mean what we need to find is d by dy of f of x, fx, right? So it is basically fx of 0, h minus fx 0, 0 limit h tends to 0, right? So fx we can actually find out using the similar method, or we can directly take the derivative, right? So if I take the derivative, fx is this, right? That will be little time taking, but it is easier method, trust me, because if I find this thing separately, then it will be little challenging in this approach of writing limit. So okay, so let's first take the derivative with respect to x. So 4x square is 8x tan inverse y by 2x multiplied by plus 4x square multiplied by 1 plus y square. Just give me a minute, my pen is malfunctioning somehow. So we are back. So yeah, so first now we'll take derivative of tan inverse. So 1 by 1 plus y square upon 4x square, and derivative of the y by 2x with respect to x is minus y by 2x square, right? Plus second y cube's derivative is 0, so no need to worry about this. So y cube multiplied by 1 by 1 plus x square upon 16y raised to the power 4 and then 1 by 4y square. This is my derivative, right? Now yeah, so at 0, h this quantity, I mean we can simplify a little bit further before diving into this thing. 8x tan inverse 1 by 2x, this is first thing, plus I can cancel this thing by 2, so minus 8 x square y by 4 x square plus y square, plus I can actually cut this thing, so 16 into 4 64, not 64, so 4 actually 4 y 5 by 16 y 4 plus x square. So this is my final thing. Now fx at 0 comma h. Fx at 0 comma 0, let me just find out. So 0 comma 0 is undefined here, but yeah, because there is x outside, so it will be 0. And now it is 0 comma 0 again, but this will be 0 once again. Why? Because if I take the limit at x comma y tending to 0, I will get 0. You can put y equal to mx. So the degree in the numerator is higher than the degree in the denominator. Similarly, degree is higher here as well, so it is 0. So fx at 0 comma h, right? So 0 comma h is basically the first quantity is again 0. The second quantity, if I put x as 0, it is again 0. The third quantity is 4h raised to the power 5 by sorry for my pen's malfunctioning, but I think it is visible. 16h raised to the power 4. It is basically what? 1 by 4 h. So this is basically limit h tends to 0. H by 4 upon h is basically 1 by 4, and the answer, that is why it will be 0.25. Now we will be solving question number 10. So question number 10 is about sequences and the convergence of the sequence. So xn and yn are given two sequences. We need to find whether it will be converging or not, right? So let us start with any one of the sequence. So let me start with yn, right? So yn is what? Yn is 1 by n integral cos t by t square dt, right? My pen is a little bit malfunctioning, so that is why the handwriting is not that good. Yeah, but we'll adjust. So what is the meaning of convergence of a sequence? Convergence of a sequence means that limit n tends to infinity, yn must exist and is finite, right? So if I can find a value of 1 power 1 to infinity cos t by t square dt, that means yn will be converging. I know that this thing will lie between dt by t square 1 to infinity and minus dt by t square 1 to infinity, obviously, right? Because cos x lies between minus 1 and 1. So if I integrate this, I'll have what? T power minus 1 by minus 1, 1 to infinity, that is minus 1, that is 1 basically, and it is negative of that, so it is minus 1. So this particular thing lies between minus 1 and 1. We can see that if t tends to infinity, this thing goes to 0. So what do I mean by that is that it tends to 0, in fact the individual term tends to 0. That means the series cannot oscillate, right? That means the series will have a value between minus 1 and 1, and if I can find a value, that means limit is existing and it is not oscillating, that means limit is existing, so yn will be convergent. In other words, if I know that this thing's mod of this is less than or equal to dt by t square 1 to infinity, right? And that means it is less than or equal to 1, yeah. And also limit t tends to infinity, this thing will be 0, right? So if this series is absolutely convergent, that means this will also be convergent. So yn is convergent by default. So not convergent options are ruled out. Now what about xn? Xn is basically, I have to find out the value of limit x tends to infinity 1 plus 1 by 2 up to 1 by n minus log n. Now this thing is going to infinity, this thing is going to infinity. Infinity minus infinity can either be infinity or it can be finite. If it is finite, then it is convergent, otherwise it does not. So it has a chance that it can converge, right? Now to find out that how are these two infinities related, I need to find out how this quantity, what is the relation between this sum and log of n. So I need to compare between this sum and log of n. If this sum is closer to n, then n minus log n will tend to infinity. We know that n is very larger than log n. If this thing is like log of 1 plus n, I know that log of 1 plus n is same as log n. We can find out limit n tends to infinity log of 1 plus n minus log n. So it is basically limit n tends to infinity log of 1 plus n by n, and 1 plus n by n is 1 as n goes to infinity, so log of 1, so it is 0. So if this infinity is type log of 1 plus n, then this subtraction will be 0, will be finite. So I need to find out how this is related to log n. So basically we can do the exact same thing that we did previously. So I know that summation k is equal to n is equal to 1 to infinity 1 upon n. It's less than or equal to, I have this idea, right? I can 1 upon t dt, I can do 1 plus 1 upon t dt, sorry. So I have this thing everywhere. You have seen it in series that the sum of finite series is basically, this is the discrete summation, is basically it lies between these two bounds. Sum of anything an is less than or equal to 1 plus an dn, basically 1 to infinity, and an dn 1 to infinity plus 1. Why this happens? Not infinity plus 1, basically it is not, you can take up to any term, up to t, up to let's say alpha, you can take up to any term, it can lie between those two terms. Why this happens? It happens due to the very good graphical reason. If you want to explore, you can explore otherwise, but I'll not be discussing this here. If we do so, we know that I can rewrite this thing again as sigma 1 by k is equal to 1 to n, lies between dk by k 1 to k, outside there is 1, and it lies dk by k 1 to k plus 1, sorry, n plus 1. So it lies between 1 plus, if you do this, it will be log n, right? And it will be log n plus 1. So this quantity basically lies between 1 plus log n and log n plus 1. So this quantity, if you do this, if I subtract log n, so sigma k is equal to 1 by n 1 by k minus log n lies between 1 and log n plus 1 minus log n, and I know that this is basically 0, so it is lying between 0 to 1, so I am finding a value of this term, right? So yeah, xn is also convergent, so option 2 is correct.